Electronically monitored fire sprinkler heads, the future of fire protection.
Cleanup underway at Cassopolis High School. A sprinkler pipe broke in the kitchen, and that caused hundreds of thousands of dollars worth of damage. That means school is closed for the rest of the week. WSBT's Rachel Lake was at that school tonight. She's at the live desk tonight. Rachel, you think about the damage here. We're talking half the school was flooded.
Yeah, the school spans 130,000 square feet, Jen, and half of it was covered in water. Superintendent says at one point, 2,000 to 3,000 gallons were flowing out of the pipe a minute, and now they've got a long way to go before everything is back to normal.
Including fire sprinkler systems. Here again is KSU's Kim Passel.
It's been really busy for you guys.
Yes, it has. It's been very busy.
Oklahoma City firefighters spent their day mopping up and think they'll stay busy with calls of bursting pipes and sprinkler systems overnight.
And you probably will see more as the day goes on.
Crews pushed water out of the Timberwood Assisted Living Center this afternoon after their sprinkler system flooded several of the residents' rooms. Firefighters report at least a dozen other businesses also had their sprinkler systems malfunction, and they've responded to 5 calls of pipes bursting.
This was a real mess. It has been nearly 1 year since the monsoon did a real number on our Phoenix Public Library. Water flooding Burton Bar Library downtown. So, and then we come to find out that all that water wasn't actually from the storm itself. It was from a sprinkler system that was damaged by the storm. So now we're looking at almost a year later, $10 million later, to get the doors open, and they just did. So last year flooded by water, this morning flooded by people. Yeah.
Hi, I'm Justin Mull, founder and inventor of electronically monitored fire sprinkler heads, also known as EMFSH. This innovative idea is the future of fire protection and will now allow us to not only protect structures from fire damage, but we can now also protect them from unnecessary fire sprinkler water damage as well. With over 20 years experience in this industry myself and my family with over 80 years combined, I've heard countless stories, and there have been numerous times I've been called out on an emergency call where the sprinkler pipe had been damaged or failed due to natural causes or simply just human error. The water damage in these cases was so extensive, the entire buildings or houses had to be evacuated. The drywall, carpet, hardwood floors, and other miscellaneous interior components had to be removed due to the amount of flooding that had occurred. Now keep in mind, there was never a fire in any of these instances that set the systems off. It was merely a simple accident. For these reasons is why I knew there had to be a better way to prevent these unnecessary situations from happening, and ultimately why I came up with electronically monitored fire sprinkler heads. I've always felt there's no reason why the water should be flooding places and running for over 30 to 60 minutes when there was never even a fire. So I want you to ask yourself this one question. Why not shut the water off, right? Well, now we can, and we will. I will now be showing you an informational demonstration of this concept and running it through several different scenarios while answering some commonly asked questions at this time. To start off, I like to point out some components used here in our system for some of you who may or may not be familiar with them. We have put together a mock-up fire sprinkler riser on this display board here, and starting at the bottom, we have our incoming city supply. Right above that, we have our main control valve with internal tampers. Next up, we have a new component, which are actuator valve that shuts the water off automatically. Right above that is our typical flow switch device that monitors the flow of the water. Here's a water pressure gauge and our main drain valve. Above that is a solenoid release valve for the auxiliary drain line. Then you have your pressure relief valve, and here's the proposed electronically monitored fire sprinkler head. Now this head is not an actual head wired to operate at this time and only used right now for display purposes so that we can see everything, how it works without spraying water. Now that I've shown you some of the components used here in our system, I like to run the system through its first scenario. Scenario 1, normal operation. Normal operation, you have a sprinkler head going off and you have a flow switch monitoring the flow of the water, sending alarm signals to the panel. The system will work in normal operation and continue to fight the fire as designed. Here's how that works. Activate the switch. You have a sprinkler head flowing water. Simulate the water flowing. Soon after, the flow switch device will send an alarm signal calling the fire department. This is normal operation. I now have to shut the system off manually. Here in scenario 2, I like to show you a simulation of a broken sprinkler pipe. What I'm going to do is simulate a broken sprinkler pipe by opening the main drain to flow water. And then you'll watch the system work all on its own. So here we have a broken sprinkler pipe. Water starts flowing. The flow switch will detect it, send it to the alarm panel, and the system will shut down all on its own. Here in scenario 3, I like to demonstrate what would happen if we had a fire after we shut the water off. You'll have the water to the sprinkler system completely drained at that time, but then a head is activated by a fire that started after we shut the water off. I'll show you how that works. You have a broken sprinkler pipe, and you don't have a sprinkler head in alarm. So the system naturally is going to shut itself down and drain it all on its own. So I'll silence that alarm at this time. But say we have a fire after this happens. Sprinkler head goes off. System turns itself back on, shuts the drain off, and continues to fight the fire as designed. At this time, I'll have to shut the water off manually. Here in scenario 4, I'd like to demonstrate what would happen if we shut the water off due to a broken sprinkler pipe, but then we lost power to the system or the building. The actuator valve is designed with a battery fail-safe normally open position. So when it detects a loss of power, it will turn everything back on, creating a live system indefinitely until the power gets restored. Here's how that works. We have a broken sprinkler pipe. Water starts flowing, and the flow switch goes off. It'll now shut itself down. And we'll silence that alarm. So now I'll take the power off the system as if there were a lightning strike, power failure, or something happened, and the alarm system will detect it. Shortly after your loss of power, you're going to get an alarm signal in the alarm panel. as that alarm comes into the panel, we'll silence it, and in 24 hours you have your batteries for your backup supply. As soon as you lose battery backup power, the system will detect complete loss of power and turn the system all back on by itself. You lose power, and the system turns back on, flowing water through the broken sprinkler pipe you already had, or the open sprinkler pipe and sprinkler head you may have now. At this time, I'll have to shut the water off manually again.
Electronically monitored fire sprinkler heads, the future of fire protection.
I'd like to thank you for your time to watch this presentation of our electronically monitored fire sprinkler assembly. If you have any questions or would like to schedule a meeting, please feel free to call or email me at jmull.emfshsprinklers@gmail.com. Thanks again. I look forward to meeting with you.